Assalamualaikum and hi, my name is Wanur Aina Syahirah binti Muhammad Zawi, one of the member in this group. Today I would like to present about nuclear reaction. This slide represents about introduction to nuclear reaction. Nuclear reaction is the process whereby the structure of nuclei is changed after bombardment with energetic particles. An alpha particle, a gamma ray photon, a proton, a neutron, or a heavy ion may be the bombarding particle. Energy is absorbed or released during a nuclear reaction. In nuclear reaction, the total atomic number and total mass number must be always equal or balanced on both sides of the equation. This is the types of particles in nuclear reaction. It have alpha particles, beta particle, positron, proton, neutron, and gamma ray. Next, balancing the nuclear reaction. A balanced chemical reaction equation reflects the fact that during a chemical reaction, bonds break and form, and atoms are rearranged, but the total numbers of atoms of each element are conserved and do not change. Regarding to conservation laws, nuclear reaction balance in two ways. First, the sum of the mass number of the reactants equal the sum of the mass number of the product. Second, the sum of the charge of the reactants equal the sum of the charge of the product. Reaction energy or Q value. Energy is released in a nuclear reaction in the form of kinetic energy of the particle emitted, the kinetic energy of the daughter nucleus, and the energy of the gamma ray photon that may accompany the reaction. The energy is called the reaction or disintegration energy, represent Q. It may be calculated by finding the mass defect of the reaction, where mass defect equal to mass nucleus before reaction minus mass nucleus after reaction. And the reaction energy Q is the energy equivalent to the mass defect lambda m of the reaction. Q equal to lambda m multiplied with C power of 2. And you must note about the value. If the value of lambda m or Q is positive, it means the reaction is called exothermic, in which the energy released in the form the kinetic energy of the product. If the value of lambda m or Q is negative, the reaction is called endothermic, in which the energy needs to be absorbed for the reaction occur.
Hello, my name is Nakib. So we go for the next slide. Chain reaction. A chain reaction is a process in which neutron released in fission produce an additional fission in at least one further nucleus. So this process will repeat again and again, and if each neutron releases two more neutrons, then the number of fissions double its generation. In that case, in 10 generation there are 1024 fissions, and in 80 generation about 6 times 10 power of 23 a mole of fissions. Chain reaction also obviously occurred in nuclear reactor, and the conditions to achieve chain reaction in a nuclear reactor: firstly, slow neutrons are better at causing fissions. Secondly, the fissile material must have a critical size, which is defined as the minimum mass of fissile material that will sustain a nuclear chain reaction. Then, the uncontrolled chain reaction are used in nuclear weapons. As example, atomic bomb. And the controlled chain reaction take place in nuclear reactors and release energy at steady rate. So, this is the example of atomic bomb. Next is nuclear fusion. Nuclear fusion is a reaction in which two or more atomic nuclei are combined to form one or more different atomic nuclei and subatomic particles, as example neutrons or protons. The difference in mass between the reactants and product is manifested as either the release or the absorption of energy. Here I provide the example of fusion reaction releases the energy. So these two reacting nuclei in fusion reaction above themselves have to be brought into collision. As both nuclei are positively charged, there is a stronger repulsive force between them, which can only be overcome if the reacting nuclei have very high kinetic energies. And these high kinetic energies imply temperatures of the order of 10 Kelvin. And then, at these elevated temperatures, however, fusion reactions are self-sustaining and the reactants are in form of a plasma. The nuclear fusion reaction can occur in fusion bomb and in the core of a star. Deuterium-tritium fusion is other example of fusion reaction. We go for the last part of my slide, which is self-expression and opinion about people out there about nuclear and how nuclear works in their life. So, nuclear power has a major role to play in the clean energy transition, but for decades, its use has been a divisive topic among the public, with public opinion playing a major part in how governments choose to produce energy. Addressing this long-standing debate will be a key part of a sustainable, clean energy transition. People nowadays keep questioning themselves about, is it important nuclear in our life? So the answer is yes. Why do you think nuclear is important? Because of we live in a warming world that is causing species extinction, making life harder for those already living in poverty and burdening economies worldwide. To reverse these trends, lift people out of poverty and improve air quality, we need clean energy options, and nuclear is our only real option for reaching zero carbon emissions. Not only does it take up little space, but a single plant can provide 80 years of clean energy. Without this renewable energy, we often see countries ending up using coal or natural gas to fill energy gaps. The nuclear industry needs to speak up and help the public see how it has owned its mistakes and address the public's fears so the world can embrace nuclear for the incredible solution there is, instead of being afraid of it. So here the example that I provide from the internet shown that a public researcher do a research about people, why people not always in support of nuclear and what changed her and other people's mind. So she heard many negative myths about how harmful nuclear waste and radiation are. In fact, in the environmental movement, which she have been involved with for most of my life, most people simply believe these myths. So I took the incident at the Fukushima. So she told that she believed about the number of deaths caused by radiation for the Fukushima accident. She believed had been that many people had died due to radiation from disaster, but the truth is that none had. This led she to dig deeper, and she found that many of her ideas about waste were unfounded, and that nuclear is actually a much safer option than fossil fuels, which many countries are still heavily used on.
Assalamualaikum warahmatullahi wabarakatuh. My name is Harith Hikmah bin Shahrazan and my student ID is 20206169774 and I am from AS 120418 which is group 18. Firstly, I will explain about nuclear fission. Nuclear fission happens when a nucleus breaks into multiple smaller fragments as it fissions. The mass of these pieces, known as a fission product, is roughly half of the initial mass. There are also 2 or 3 neutrons emitted. The total mass among these fragments is smaller than the total mass of the original. According to Einstein's equation, the missing mass, roughly 0.1% of the original mass, has been converted into energy. Fission can happen when a heavy atom nucleus absorb a neutron, or it can occur on its own. Next, I will explain about nuclear reactor. A nuclear reactor, also known as an atomic pile, is a technology that is used to start and control nuclear chain reaction or nuclear fission reactions. Nuclear reactors are used to generate energy in nuclear power stations and for nuclear marine propulsion. Some reactors create isotopes for medicinal and industrial purpose, while others produce weapons-grade plutonium. Now, I will share the top 4 countries with the most nuclear reactors in operation. The first one is United States with 93 nuclear reactors, followed by France with 56 nuclear reactors, and China with 51 nuclear reactors. And the fourth country with the most nuclear reactors in operation is Russia with 38 nuclear reactors. Now, let's see the application of nuclear reaction. And of course, the nuclear reactors will be the application of the nuclear reactions. There is two types of nuclear reactors. The first one is pressurized water reactor and the second one is boiling water reactors. But the question is, how does the nuclear reactor work? The first step, nuclear power plant use the enormous power of nuclear fission to generate heat and energy. When a neutron collides with a bigger atom, it breaks it into two smaller atoms. When a reactor is turned on, the uranium atoms in the core split, releasing neutrons and heat and igniting a chain reaction that generates more neutrons and heat. The second step, it happened at the pressurized water reactor. Pumps transport heat water from the reactor vessels to a steam generator. The water pump from the reactor is used to heat a separate supply of water, which boils to produce steam. And the last step, the steam spins the turbine, which drives the generator that produces electricity. For boiling water reactors, the first and third step is the same as pressurized water reactor. The main difference is inside the reactor vessels. Inside the reactor vessel, water is heated and steam is produced. Fission heats water when it is forced up through the reactor core. The steam is sent straight into the turbine, which generates power. Even though nuclear reactor is absent in Malaysia, my teammate and I agree to share awareness as a general knowledge. So there is 3 steps on what to do if there is unfortunate incident of a radiation emergency. The first step, we have to get inside and choose a location away from the doors and windows, such as the center of the building or a basement. If you have enough time, bring your pets inside. The second step, we have to close all the windows and doors and make sure that we quickly shower and use moist towel to wipe exposed area of your body. And the important part is, we have to drink bottled water and eat food that has been sealed only. And the last step is, we have to get the most up-to-date information from the radio, televisions, the internet, mobile phones and other sources. Information on where to undergo a contamination screening will be provided by the emergency officials.
The social responsibility is the ability to evoke dread in human beings must be counted as one of the key properties of radioactive waste, not just a passing fact about human life. Not to know the essential fact about nuclear waste is like not knowing their half-life, their thermal qualities, or any of their other physical and chemical characteristics. Medical care assists in corporate tasks like development and running of essential well-being focus with works, giving portable clinical van administrations, putting together clinical camps, giving prenatal and postnatal consideration, financing improvement and expansion of emergency clinic, blood donation center office, giving clinical treatment, prescription and corrective supplement (OPD) administration for local. Next, foundation development assists in corporate ventures like development of approved street spans, improvement of drinking water office, development of local area lobby, development of transport, stop or sheds, establishment of street lamps, giving office to agribusiness, cultivating, fishing, and other neighborhood job accesses, maintainable development accesses like preservation of neighborhood widely varied vegetation, fishes, turtles, birds, butterfly and mudfalls, timberlands, backwater cleaning and preservation of land, water and air assets, downpour water collecting, expulsion or cleaning of water hyacinth from water body. All of that can help to reduce effect of radiation. That's all from us about nuclear reaction. Thank you.